So often they feed on the host and may weaken it and may kill it, but typically they maintain it. It remains alive so they can continue to feed. And lots of examples of parasites. A large percentage of the animals of the world are actually parasitic. Tapeworms and many bacteria included. So here's the cowbirds. You can hear them up in the hills. This is the example of a brood parasite here from Berkeley. We went on one of these informal 1B hikes one semester and could not believe my eyes because I'd never seen it. When I don't see these birds in Berkeley very often up in the hills. They tend to be more associated with agricultural areas. But we saw one of these guys up in the forest up there, and it was with, these are not my pictures, but it was with a little warbler, very much like this big baby cowbird. And the warbler was working its butt off, feeding that cowbird, because that cowbird had hatched in its little nest, kicked out the other eggs, and been raised by the little warbler, just like the cichlid brooder and the catfish. And she spends all this energy and time feeding, physically catching insects, and she was flying off, and the little bird would sit there squeaking on the branch and flapping its wings pathetically, and then she would come back and feed it, and then it would squawk and scream, that's not enough, that's not enough, that's not enough, and it would go off and do it again. It was incredible. And that's one of the problems with these cowbirds, because they're invasive species in many areas. Their range has expanded into areas where they did not previously exist, and not only are they competing for resources with other birds, but they're laying their eggs in the nests of native species and causing havoc in that regard. Pretty incredible case of parasitism. Doesn't kill the mom bird, but wears her out, and probably influences the growth rate of the population. Many plants are parasitic. You go down to the marina, down to the bay, off of 80, if you're driving on 80, and you look in the salt flats, the marshes just on the bay down there, you'll often see little orange patches. That may be salt marsh dodder. That may be the plant dodder. That's a parasite on the pickleweed that grows there. And this parasitic plant actually inserts these specialized organs called haustoria into the phloem of the pickleweed and captures its food, takes its food. This orange plant does not photosynthesize itself. It's parasitic on the photosynthetic pickleweed. So check it out when you're driving on the highway for those little orange patches of dodder down there. Impress your friends. Parasitoids, in contrast to parasites, usually have one host species and they're lethal to that. The individuals of that species. Many of the wasps, and we've talked about wasps a bit, many of those are parasitoids. Again, a huge number of insects are actually parasitoids. In this case, the wasp has found a caterpillar and laid its eggs on the caterpillar, and then the eggs hatch, and the young form these cocoons on the caterpillar, and then when those hatch, when the wasp hatches out of these cocoons, they'll devour the caterpillar and go on and find another caterpillar. And so these wasps are very useful agriculturally if the caterpillars are a problem. And gardeners are encouraged if they see something like this and let it go. Leave it like that because it's going to hatch a whole bunch of other wasps and help to manage the population of caterpillars that may be eating your leafy vegetables. Mutualisms are the case where both interacting parties benefit from an interaction. This didn't receive nearly the amount of study that the negative interactions received in the history of ecology. It wasn't even until the 70s or 80s, 1970s or 1980s, that mutualism started to get a focus of attention. But now we know there are a huge number of mutualistic relationships, whether obligate or facultative, whether the participants require the interaction to survive, or whether they just benefit from the interaction but they could survive without it. Clownfish and anemones are the classic example of mutualism, and still under study, but what it appears is that this relationship is obligate for the clownfish. The clownfish, if separated from an anemone, can't survive for very long. In some cases, there are lots of clownfishes, but in some cases that's the case. Whereas the anemones benefit from the presence of the clownfish because they help to attract other fish that the anemone feeds on, but it can survive, the anemone can, without the clownfish. So that's a case of one interaction that involves both obligate and facultative mutualism as part of its relationship there. Other examples of mutualism? There are tons. Nitrogen-fixing bacteria, mycorrhizae, a relationship between fungi and plants in the fungal roots, lots of things you'll learn in botany about that. Lichens are symbioses, mutualistic associations. Ants can form mutualisms with aphids, where these ants protect the aphids that are drinking the sap of the plants from predators, but they milk the aphids and drink the nectar from the aphids, but also protect them. So they're essentially treating them like livestock. They're farming these aphids, the ants are.
To look at them, you never know it, but these ants are fungus farmers. The leafcutter ants from South America are the epitome of teamwork. Living in colonies of several 100,000 to a million, each ant has a specific role to play within its colony, and each one of them depends on this fungus to survive. The relationship between the ants and the fungus is exclusive. Neither one is found in nature without the other. The ants cut discs out of leaves and carry them to underground nests. Then, they shred the leaves and use the material for growing a fungus. Inside the huge subterranean fungus gardens, thousands of ants work to cultivate the fungus.
Many different types of relationship. One of my favorites is the hunting association that you get between carnivorans. Another association between honey badgers and honey guides exists in Africa. Not that well studied. It's a tough one to study, but the bird basically signals the presence of beehives to the honey badger that will follow the bird to those hives, break them open, and strew the honey and larvae about that the bird can pick up. So the honey guide, that's the name of the bird, guides the badger to the honey and then benefits from the badger having torn the nest apart. But the one that I find so fun is between coyotes and American badgers. This was documented in the literature starting about 120 years ago, but never really studied because it wasn't watched consistently. It's kind of a tentative relationship between coyote and badger. They don't like each other that much. The badger tolerates the coyote. The coyote seems to have the upper hand in the relationship. But when they hunt together, they both do better in terms of catching rodents, burrowing rodents in particular. The coyote can dig. They're great diggers, but they're not the diggers that the badgers are. And so the badger focuses on rodents below ground and does the primary digging, where the coyote's running around above ground. And when the badger's digging and flushes the rodents above ground, the coyote's there to scare them back below ground, and that increases the hunting success of the badger below ground and also the coyote above ground. So when they work together, they actually catch more squirrels or whatever burrowing rodent they're after. And these early settlers in the West would be in their, they describe these things in their diaries. They're sitting in camp in the morning making their tea over the fire, and a badger and a coyote go hippy-hoppy across the landscape together like they're best friends forever. And it's just the oddest thing. It's just the oddest thing to see two carnivores like that teaming up. But they do it just temporarily. At some point, the badger gets sick of the coyote, and basically, the coyote will eat the badger's babies, and the badger will eat the coyote's babies, and it's a tenuous sort of alliance. And that's something to keep in mind with a lot of these relationships. They're not fixed. They're not fixed for the species. They can shift. What's mutualism one day can be predation the next day. And they shift evolutionarily. They don't just shift on daily or seasonal basis. Evolutionarily, they can change. Something can start as a active predation, but can turn into a mutualism. Lots of examples of that. Competition is a huge category of relationships and has received the most study. It's considered by many ecologists to be the fundamental structuring factor in communities. At least it was 10, 20 years ago. It's been the focus of study since Darwin. And we can distinguish a couple of types of competition: exploitative and interference. In exploitative competition, you have a focus on a resource that's in limited supply by two different organisms that may not even interact together. So this bison and this grasshopper may be feeding on the same plants, even though they don't even interact that much. But because they're feeding on the same plants, they're limiting resources for one another because they're exploiting a common resource. Exploitative competition. Your resource is used by the two competitors, even though the competitors don't interact directly. That's the point of the dotted line. They do interact because of a shared common resource, and they compete thereby. So you can't have competition unless your resource is in limited supply. We're all breathing oxygen in here, but we're not competing for it. No one's getting angry with the person sitting next to them because they're taking too much oxygen, because it's not limited. You don't compete for something unless it's limited. In interference competition, the interaction is direct, a direct physical encounter. You can just think of it as a physical interaction, compared to the exploitative, which is indirect. Here are your links to your rhino beetles, if you want to watch videos on those. Lions chasing hyenas, one of the favorite things for lions to do. Another type of competition is there's competition for space, because space is often limited for organisms. Organisms compete for space. Organisms may particularly compete for space where enemies don't exist. For example, predators. If you're on a reef and there are only a handful of shelters that are predator-free, those are going to be highly sought after and competed for. So competition for enemy-free space is another type of competition. Here, this urchin found a little hole where it's going to be immune from the predation of, say, sea otters, because they can't pull that urchin out from its little crevice. But another urchin that's here, not able to dislodge this urchin, is going to be eaten. So a table, I'll let you look on it on your own time, but just to help you categorize those interactions: commensalism, facilitation, amensalism, competition, mutualism, consumer resource, based on the effect they have on the participants. The competitive exclusion principle you were introduced to in lab. The famous studies of Gauss, the Russian biologist Gauss, his experiments on paramecia. And I can summarize the basics of those results to introduce the principle. Well, his and subsequent studies show that when certain paramecia species are grown by themselves, they tend to show a S-shaped curve by themselves. When grown with another species, so here's that first species grown with a second species, they also are showing a trend toward carrying capacity, but at a lower population density. And the same for this second pair of species. Here is Bursaria, Paramecium bursaria, grown by itself. Here's Paramecium bursaria, grown with another species. When it's by itself, it has a higher carrying capacity than it does when it's grown with a second species. These are cases where the two end up coexisting. The two species pairs can coexist. They're not driven to local extinction. The classic study that's usually cited is the one in which, when the two Paramecium are grown together, Aurelia and Caudatum falls to 0 in numbers. It's driven to local extinction because Aurelia, on the interpretation of Gauss, was somehow a superior competitor in this environment and dominated the resources, drove the other one out. And on that basis, he formulated a really influential principle. We don't have many laws in biology, so we have some principles in ecology that are as close as you get to a law. That's what he meant by this, or that's what subsequent people have meant by calling this a principle. It's quite controversial itself. But if you want a way to define it, if two competing species coexist in a stable environment, they do so as a result of ecological differentiation. If there is no such differentiation, then one species will eliminate or exclude the other. So that defines it more in the context of niches that I'll now talk about. Sort of a different way to think about the exclusion principle, but one that's consistent with, mostly consistent with other definitions. Now, the environment is recognized as being stable because environmental dynamics, extrinsic to the competing populations, may influence the numbers of those populations in a way that can override any competitive influence that exists between them. So we need a niche concept. And a helpful place to look for one is in the classic studies of Joseph Connell on barnacles in Scotland. Hang out with me for 3 more minutes, and then I'll let you go on time. We'll finish probably with a niche here. And we will distinguish realized niches from fundamental niches. The whole subject of the niche is fascinating. The history is great, and we won't have time to do very much with it. We'll give you a basic introduction to the niche from Connell studies. So what he did with these barnacles, and you've probably heard about it somewhere, maybe in a textbook. There were two species that predominate on these in the intertidal zone on these shorelines, with Chthamalus higher up toward the high tide line and Semibalanus lower down toward the low tide line. And this would be a typical distribution of their populations. This is what is realized in nature for these populations when they're in the presence of each other. So these are their realized niches. They're niches in reality, or in terms of what you actually see when you go out and look at them when they're growing together. Experimentally, he removed Semibalanus from its occupation of the lower range and found that Chthamalus came to occupy that portion of the habitat. They were only restricted from it by the presence of Semibalanus. Somehow it was a superior competitor, according to their interpretations, in that region. In contrast, if you remove Chthamalus up here, Semibalanus is not going to occupy that area because it will desiccate. It can't handle the exposure to air. So for Chthamalus, this is its fundamental niche. This was what its niche would look like in the absence of the competitor. Whereas for Semibalanus, its realized niche was consistent with its fundamental nice way to think about those two concepts. I'll start with this next time. Have a nice day.